Hi, this is Greg Hoopman. In this video, I'm going to talk about how to code running totals hundreds or even thousands of times faster using Windows functions. I will first show you three methods of programming running totals using TSQL. I will then show you demos of these methods against three different tables: a small inventory table, a 1 million row sales table, and a 500 million row sales table. We will then evaluate the performance of each of these programming methods. First, I need to tell you about a very painful story. Several years ago, before I used window functions, or hardly ever used them and didn't know much about them, I was given a task by my manager to update an inventory file with 1.5 billion rows. Now, I've moved around data before, and 1.5 billion did not intimidate me that much, But when you talk about updating or creating a new column and placing value for every row in that column, that is different and basically sums up all the rows prior to it, you start to understand how difficult and how long such an operation might take. You'll see the method I started with, which was, like I just said, I went back and went to each row and summed everything up prior to it, and based on the item. But when I calculated how long that was going to take, it came to be like a week long. 24/7. It was crazy. I really underestimated what 1.5 billion updates would take, especially in this way of doing it. And we were working with Postgres actually at the time, and it's an old version, and so I didn't even think it did Windows functions. But we did find out that it did, and that's really got me moving more on window functions in SQL Server. So that's my painful story. We did get around it. We tried many different solutions until we came to the Windows function, and the Windows function is what really helped us tremendously solve the problem. Okay, we're going to get started with an inventory table. Now this table is very small, and I'm going to create it right on the fly here. It has about 18 columns or 18 rows. But it helps for me to illustrate the methods that I'm going to use in the bigger tables later. And we just want to make sure you have a real proper understanding of what this rolling total does. Okay. All right. So let's just look. First of all, I'm just going to create this table called inventory. Okay. So drop and create it. Okay. Then I'm going to. Actually, this step probably is totally unnecessary. Just added an index to it. This is unnecessary. But then I'm going to insert a bunch of rows. Okay, 14 rows. And now I'm going to query this. Let's just query it real simple like. Okay, so you just kind of see what the structure looks like. So the structure gives us a day key, a month year, a product key, and an amount. Okay, the month year really isn't used in this scenario, this demonstration much. But anyways, what we have is an inventory. So what we have is a lot of inventory coming into the, let's say, warehouse, and each one of these is units. Okay, and then whenever a sale is made, we're going to say it's a negative, so a negative 10. So in this case, there was a sale made for 10 units, and it was depleted out of the inventory. Then 22 was added, 20 was added. And we're going to do this by item. We're just going to keep a running total. So I want to have another row right next to it that gives me a running total of it. Okay? So let's just go ahead and run this next query which is the one I told you about. That's the slow way. I mean, right now it's a medium because we have 14 rows, but you put 1.5 billion rows, it's a whole different ballgame. So anyways, let's look at this data now. So we have 15 came in, and 15 is what our running total is. Then negative 10 came in, so it decreased to 15 by 5. And then 22 came in, and now we're increased to 5 to 27. 20 went to 47, etc., right? And that's for my ABC product key. From an XYZ, you see it starts over, and I have a 5 and a 5, which makes sense. Negative 15, so that was a negative 10. 11 is added to the negative 10, makes it a 1, right? And a 20 is added to the, and so on, right? Okay, no big deal. That's just basically what this running total does, okay? Now let's take a look at this, how I wrote this. Basically, I'm just doing a select, which gives me these guys here. These are the columns that are in the table itself, right? And then I do another select in the column here, which runs it against all the previous. So if it's sitting on this particular one, it will sum. It will do a sum amount on everything where the date key is less than that or equal, right? So we'll include it and go less than. And where the product key equals product key, so that would see this product key equals itself, right? So and then it groups it by product key. So that's how I run this. This is a typical way of doing a simple running total, but performance-wise, it's very poor when you come to big tables. Little small tables is no problem. Probably even, you'll see even a million rows, it still doesn't have that much problem. So when you get to the really big tables, it will have a problem. So that's how that works. If you want to study that, you can just pause the screen and look at it. But again, it's a select sum amount from the inventory where the date key is less than the outer, right? The A, see the outer date key? The inner date key is less than the outer date key. And the product key equals the outer product key. And then it's grouped by product key, and it gives the name running total. Okay, so that's one way of, that's the first method of using this approach, okay, to get the proper result. Now this is a proper result. Okay, now the second way, which what I'm going to call the fast way, is using a Windows function. And the Windows function we're going to use is right here. Okay, and it's not as intuitive as you might think, because the partition by product key, that makes sense, right? Because we're going to do product key just like before. Then it orders it by date key, but it doesn't tell you it's summing over everything, you know, the order before the current row, but it does. Okay, that's something you have to recognize. So you have to have that order key, order by in there in order to get this this running total type thing where it just adds up everything prior to it. Okay, and then as opposed to that, you have just a sum amount over partition, right? So that isn't the same thing. It doesn't give you the roll up beforehand. It gives you the total for each of the product keys. So I want you to take a notice of these two differences here. And the difference, to make it a running total, you have to add the order by part to that sum over partition, right? And if you were just going to do the whole table and just do a running total for the entire table without any partitioning, you know, where you didn't do it by item, but you just did the whole thing. Let's say you're running sales for the day, and you don't have to do it, you know, break it up at all. Then you don't even have to have the partition by. But anyways, so this is how this works. So I'm just going to run this query, and what we're going to see again, and this is for just for you to see the difference between just getting the full sum amount for the whole product key, and then getting a running total for the product key. So it's two different things, and you need to take notice of that and understand the difference between them. So here, as again, you see it's just like the other one, ordered by product key and date key, and you'll see running total. You'll see the amount. There's your 15, and there's 15. Then you subtract 10 from 15, and you get 5. You add 22 to 5, and you get 27. Add 20, add 27 to 20 and you get 47, etc. So it's just like the other one, right? It works the same way. And once you get to the XYZ product key, right, changes, you start over, right? But what you want to notice here is that the second column, where I didn't do an order by, it doesn't do a running total. It gives you the ending total, which is the grand total of all of these for the product, which is 109, and puts it 109 in each one of those, okay? Okay, so I'm just, again, just showing you that extra column just for you to know the difference between a running total and a full total for the partition. Okay, and it all has to do with adding that order by to get that right. All right. Now, there's a third method to this madness. No, not madness, but anyways, there's a third method, and it's very subtle, and it's only started in 2016, SQL Server 2016, and according to Ixik Ben-Gan, a guru in SQL, everything SQL Server, Transact SQL Server for sure, also Windows Functions for sure. I'm going to give you his an article that I read about this, but it goes into much more detail. And what it does is it's going to, well, we got a Home Depot. Okay, so anyways, what this does is we have a what you have to do is create a Columnstore Index. It doesn't even have, and he calls it a dummy because it doesn't even have to have anything in it really. So as you see in here, I'm just setting month year equal to -1 and month year equal to 2, -2. And so it has nothing in it, but it needs that clustered Columnstore Index for it to do a vector type of thing. I really, you have to read his article on it to understand the nitty gritty on this thing. But what it does is it takes the normal Windows function without it and actually makes it even faster. It can make it twice as fast than this one. And this one on big tables can be 100 times faster than the other one. So this is, a 2016 deal and beyond. And it came out in 2016 in the engine. And so anyways, so it does the same, but the syntax for this is the same. You just got to have that non-clustered in there. You'll need to read the article, and I'm going to execute this also. And sure enough, we have running total. Here I have a running max. I put a max. You can do maxes, anything you want on this running stuff. Where did it go? Here we go. So you see the running max. I just use a max here. Still do the order by, and then I have the same one as the other one right here. So this is for demonstration purposes, so you can understand in this small table what the functionality of the running total is. Okay, now let's get to where the Ixik's article is, and I recommend you reading this for background information for sure. But here it is. So it's http://www.itprotoday.com, Microsoft SQL Server, what you need to know about batch mode, window aggregate operation. Okay, so when you go there, oh my bad. Okay, I'm having a little trouble getting to that page right now, but it's Ixik Ben-Gan is the author. And this is the link I connected to him with. If not, you can't get there and just go through Google. An excellent article, as always, by him. He also does a past video on the same subject matter. And you can check that out in your SQLPast.org under Learning and under Past Summit. And you'll see his video there. And it's a must see. All right, so let's move on back to the code. So again, he goes through why this runs twice as fast, and we'll just allude to it a little bit in our next examples. So this is how the basic queries work. We're going to go into the performance now. When we go against a 1,000,000 row table, it's not going to have the negatives like the inventory does. It's going to roll up. But you know, that's fine. It's just gonna that it just won't be inventory, it'll be sales data. So let's go ahead and take a look at that. Okay, now what we're going to talk about is the 1 million row table. Okay, so we get into something where we can talk about performance a little bit. We're going to go through the same. I have a 1 million row table, sales table, called DBO, called 1 million row orders. Okay, to be very original. So basically, I'm going to run this out to a table. I'm going to do it into a 1 million row embedded select. Then we're going to look at our query plans. Okay, our actual query plans. So I'm going to set that include actual query plan on. Okay, and then we're going to see. Then later, after we're done with it, we're going to look at the query plan. And we're going to look at then we're going to validate. So let's just run that table. We're going to first of all drop the into table. I'm not sure it's out there or not. Okay, I guess it was. So now we're going to run this query. This is the original method where you do the sum over, okay, right? And we're going to compare the performance and run the execution plan. So we take a look at what the performance is there of this query. I'll come back after this is done. Okay, that came back. It took about 1 minute and 26 seconds. Let's take a look at the execution plan. And you can do it this one yourself, but you can look through here. But basically what I'm interested in is what the cost was. So the cost, as I see, where I see estimated subtree cost is 1,049. Okay, so that's the cost of that 1,049. So we'll say that's the cost, right? Okay. Now this is what you can compare in your that's our execution plan. So that's what you can compare to when you run compare it to another one, which we're going to run differently. So now we're going to run the other one. Now here's that dummy columnar index, which I've done in some tests. So I don't want that to be in this one because this is what we're using the second method on here. Okay, so I'm just going to drop that if it's there. I guess it wasn't there. So now I'm going to drop the table that I want to put this in, which is the 1 million row orders with Windows, using Windows function and without the columnar index. Okay, so I'm going to drop that table, and now we're going to, as we look at this code, we see here is our Windows function. Again, this won't use the super fast one, but this should be a lot faster. Okay, and I'm not talking duration because the best way to look at this is really in the cost that the query plan comes up with. That helps because of the duration. There could be caching and that kind of thing. Even though I've run it, I think this is the first time I've run this today. So, anyways, here's your Windows function: sum quantity over partition by product key, order by date key, and sales order number. Okay. Up in here we had it the same thing. We didn't have the same, but the same thing that did the same, which was here, was where we did a select sum, where we went back and summed everything based on a where clause. Okay, so now we're going to do this one, which is the Windows function, the faster one, which I'm proposing is faster. So we're going to select from there, and we're going to put it into that table, just like the other. And okay, that just finished. That's at 5 seconds. But anyways, let's look at the execution plan. What do you want to look at here? Okay, it's a lot easier, a lot simpler than the other plan. But let's look at what our cost is. So our estimated subtree cost was 76.4. So we're going to say 76.4 for this one. right? So the cost was 76.4, right? So 76. So what do we have on the first one? We had 1,049 and 76. Well, that's over 10 times as fast on the second one, okay? So there's one reason right there, okay? So that's without the columnar index, okay? So let's actually go look at that data. Let's look at the one at the top. I don't know whether we looked at that one. So here's the embedded select, and I'm going to stop this because in a minute. I just want to show you that it's doing what it's supposed to do. So here's product 1, as you see 7, and just keeps running the total up, right? Keeps running it up. We get to 2. When we get to the item 2, right? It starts again at 7. It rolls it up, and if we go way down to something bigger, we're at 865 on the product right now. There's 869. So let's get the break here. So all right, looks like we got this on here. Okay, so here's your 865. It finishes at 84.18, and then it restarts here 32.64.96 on the next product key. Okay, so that shows the first one worked properly, and the second one we're going to run a query against a 1 million row table with Windows function and without the Columnstore Index, and we'll run that. And again, we see the same kind of thing here. I'll bring it down a little further. We'll probably see the same thing down here. 951 is our product key. 952. Let's see the break. Okay, so 951, you went up to 1,114. And here we go. We start at 952 here, and it starts over 85, right? Okay, so both those were accurate the way they perform their functionality. And it's pretty good, pretty quick, right? So now we're going to do one more thing. We're going to go ahead and now create an we know we dropped this one earlier, this index. Now I'm going to create an index. And so you see I'm creating an index on a dummy date, 1923-0101. That's not in the data. So it will be a very small Columnstore index, or nothing, or almost nothing, but it has that in it so that the Windows function will take advantage of that. Again, I refer back to Itzik Ben-Gan's article I alluded to earlier, that you should read, and if you want to really understand the guts of that. So I'm going to create that index, okay, that columnar index. And by the way, if I'm not mistaken, 2016 has some fantastic new enhancements. I'm sorry, the SQL Server 2016 Standard Edition has some fantastic new features that were before only used in Enterprise. And one of them does allow you to use Columnstore indexes, columnar indexes. So you might want to check that out. And I think in Itzik's article, he says that it's not available in Standard Edition, but I'm questioning whether it might be, because they do now have in the, I think, SP1 all these extra features with it, which also includes columnar indexes. So you might want to try that out. It might very well work in Standard Edition also. Okay, so we created the Columnstore indexes. I'm going to delete this temp kind of table, which says with Columnstore instead of without. Okay, so I'm going to drop that. I'm not sure whether we even have one in there. We do. Okay, now I'm going to run the same code here. And again, we're looking at, remember the cost up here was 10049 for the first query, the slow query. And for the second query, it's 76. Now, this one is I'm almost certain is going to run faster because of this columnar index, because it's going to utilize that in its query optimizer. So we're going to run this. It's the same kind of code, the same exact code actually, with your sum quantity over the same concept. Okay, so let's take a look at that. Let's go ahead and it's going to run it into that table. So I'm going to say execute. That came back in 1 second. and we're going to look at that query plan. We're going to look at the estimated, and the estimated subtree cost is 31.1. 31.1. 31, right? So remember, the other one was 76 and the other one was 1,000. So 1,000 divided by 31, well, heck, that's 30 times faster. About 31 times faster, this most optimized Windows function for running totals. So it's all in the math, and it's pretty basic when you look at it this way. So just to verify, we're going to run the same query against that table we inserted into, and there it is. So you see 7, 14, 21, etc., etc. So this is a fantastic and illustration of the performance, how performant by doing a little bit of code change using these window functions, and then throwing in the columnar index. Boom! You're just blasting rocket speed. Okay, so let's move on to our next example. Okay, now I'm going to look at the 500 million. I guess it's 514 million row orders table, right? And basically in this scenario, I cannot go through all of the examples here, especially the sum here, the old style, because this would take a week and I'd have to come back in a week. It's I'm not even you know what I'm talking about. So basically what we're going to do with this particular table, this same query that I ran against the 1 million. But what we're going to do is look at the view estimated query plan, right? Okay, because to get the actual, I have to run the whole thing and I have to wait a week, and then I'll come back if it even finishes without breaking my computer with all the resources. So I did an estimated query plan on this because it takes into account the size of the tables and all that kind of thing. So it does this estimation, and it estimated 3891254. I wish I could bring my mouse over there, but I can't really do it. But anyways, if you look over there at the third row down, it says estimated subtree cost, and it's 3891250, which is 3.8 million, 3.89, or let's say 3.9 million. A cost of 3.9 million. Okay, so let's just record that. That's not exact because 8.9 million, but that's pretty big, right? And it's pretty big because it's not no longer a million rows; it's a 500 million rows, right? So the cost is 3.9 million, 8.9 million. Now, if we do the same thing here, I drop this. When I do an estimated plan here, I don't think it takes into account between the two whether columnar index is on it or not. So we're just going to look at the estimated plan here, and this is without a columnar index, right? We're going to drop it if it exists. Okay, well, it didn't exist. So again, here's our regular Windows function. And again, just the Windows function without a columnar index is incredibly improves the performance incredibly. Okay, so there's our Windows index, our Windows function, and I'm just going to run an estimated plan on it. Again, it's looking at the 514 million rows, and I'm going to go query, and I'm going to go display estimated execution plan and look at it. And here, look at that. It's 18,525 for the subtree cost. 18,520. 18,520. Let's say 524. 523 was it? How about 525? 525. Okay, that finished. What we have though, let's see what we got. It didn't take 10 minutes. It took an hour and 46 minutes. But we got to remember that was 500. I guess I was wrong on 514 million rows. It's 517 million rows. That's a lot of rows. That's a lot of data. And an hour and 46 minutes is not a problem. It's a lot better than a week or 350 hours. So let's see what the execution. Now this is the actual execution plan. So and remember that we ran this under the with the columnar index. Okay, so let's look at the execution plan and see what its estimate was. Okay, its estimated tree cost was 19,405. So let's see, cost 19,405, right? Okay, the other one was an estimated, the one above without the columnar was an estimated 18,525. So we really don't know what that actually was unless we, actually I am going to run it. So we're going to take off the columnar index. Before we go there though, let's look at this. So what we're looking for here in the columnar index, we're looking for the window aggregate. Okay, I did have a columnar index, and I'm going to go ahead then, like it's supposed to. I'm looking for the window aggregate in here, which I don't see. But nonetheless, I'm going to go ahead and run the top one. I'm going to get rid of the aggregate. I'm going to drop the index. Now I'm going to run this without the aggregate. But we're going to see what the actual is when this does this. So we'll see you in a few hours or a couple hours. Okay, finished. Again, this was the one where we didn't have the columnar index set, Columnstore Index set. And so this one ran in a minute, 33 minutes. An hour, 33 minutes. So now, as far as a query optimizer goes, it seemed to give us the same execution plan regardless of whether we had the columnar or Columnstore Index or not in this case. So it doesn't look like it works in every situation, but anyways, you're still, you still have this 20,000 or so on the actual plan versus whatever that was, 3.9 million on the estimated cost of the old way of doing things. And so you're still going to save, you're looking at about an extra hour and a half to do all this on 517 million rows and going it the other way. So there's no comparison as far as, regardless if you don't get that extra boost with the columnar or store indexes in this particular sample table. I hope this presentation has helped you in understanding Windows functions and how they can help you, especially, well, not only especially in the running totals, but overall, it's a great function, and you're going to improve your programming skills many fold just by starting to learn the Windows functions. Thank you.